Okay, on test G, number 2 had this, and this could be done with tables easiestly. And I used formula 11 when I made the video. And it reduced, let me get this folded so you can see it. 11, I should have prepared this. I used formula 11, which reduced the cosine down 2. So this is what we're kind of looking at, what's going to end up if we start with this. This is all mechanical. This is what we're going to have to still integrate. And it reduced the cosine from 3 down to 1 and left sine squared in it. Now, a lot of people use number 12. So I'm going to do it with number 12. So if I use number 12, m will be 2, and n would be 3. And if you use 12, the sign is going to go from 2 to 0. So there won't be any signs left in the integral. But we'll have this stuff. And there's a minus, so it'd be negative, division, and 1 less than the sign, which is at 2, so it goes to sine to the 1. And cosine goes up a power, so it goes cosine fourth over m plus n, so that's 3 plus 2 is 5, plus m minus 1, that's sine, so it's 2 minus 1 is 1, over the m plus n, so that's 5, integral, sine down 2. Sine is 2, sine to the 0 is 1, so this is just a 1, times the cosine to the third. Still the same n. So we have that. Now, to do cosine to the third, we can use this formula, which reduces that down to 0, and m would be 0 because there's no sign in there. And so we're just going to get n's, and sine to the 0 plus 1 would be a sine. So we'd get a sine in, cosine down to 2, and we could do it that way. But probably better would be, and easier, and basically that's what this formula would do. Number 8 would reduce the cosine power down by 2 with nothing else. And that's basically what doing 11 would do, the same thing as this. Notice it's got cosine n minus 1, sine 1 bigger than what it was. Well, there wasn't a sine, so it'd be sine to the 1. This would be sine to the 1. And over here, we'd get the n minus 1 over just n, because m is 0, and integral of cosine to 2 less, and there wasn't any sign because it was sine to the 0. So this and this formula are exactly the same, except that the m is 0. And similarly, this one is exactly the same as this formula, except n is the n in this would be 0, and so this would be the m. And you'll notice that this is very similar to this one. So these are just variations of this. These are the more complicated. These are just simplified when m or n is 0. So we could go to this formula for this. So we have minus the sine of x cosine to the fourth x over 5 plus 1/5. And if I use this one, n is 3. So 3 minus 1 is 2. So it's cosine squared x sine x over n, which was 3, plus 3 minus 1 is 2 over 3, integral of 2 less than the cosine to the third is just cosine x. And so we get this, and 1/5 times this, and the antiderivative of cosine is see, the derivative of sine is cosine, so the antiderivative is just sine. And plus a c. So that's doing problem number 2, starting with formula 12 first. And then using 8. Or you could use number 11. Both of them will do exactly the same thing and give you the same stuff there. And then you get this, and you're done.